Awesome. Thank you so much, everyone, for joining us. Thank you for the introduction. I'm Diana Smith. I'm a senior sales engineer with Precisely. I focus mostly on location intelligence and data enrichment. We also have Mayank Kasturia. He's in the audience in the first row here. He's also a senior sales engineer, but his focus is more on cloud native and big data solutions. So here's the plan for today. I'm going to give you a quick background on how we help our customers use location in their data science workflows, some of the challenges associated with those workflows, and then how we've sort of solved for those issues by creating a location-enabled lakehouse on the Databricks platform. I'll then do a quick demo on Databricks SQL, and then hand it over to Mayank to deep dive into the Precisely ID and the architecture underlying this solution. There is a ticking clock, so I'm going to try to save some time for Q&A at the end. Very good. So here are some of the problems our customers are trying to solve using data science and geospatial data. So this really spans all industries. We work a lot with insurance and telco customers looking for risk at given locations or where they should be putting infrastructure. But it's really industry agnostic. So we're seeing folks in real estate, banking, retail, healthcare, folks all over the map trying to solve these issues. And these may seem like problems that we've been solving for ages, even using location data. But the main differences that we're seeing these days are in the number and different types of data that folks are trying to use, the sheer volume of the data. It's absolutely exploding. The scalability and the cost effectiveness of the environment they're looking for. And then really this desire to use location data natively in a platform and not have to sub out the work to some specialized department or someone with specialized geographic knowledge. Data scientists aren't classically trained in managing geospatial formats, so they're looking for something that they can use natively in their platform. So let's look at one of these examples a little bit more closely. So I'm going to pick insurance because everybody has insurance and at least knows a little bit about it. So imagine you're a data science at an insurance company. That may be possible for somebody in the audience. So essentially, your goals are to help your company reduce risk and automate workflows. So the main question you'd be trying to answer is, what is the risk at a given location? So you'd likely have data sets of all of your policies and the addresses associated with that, physical risk, property building characteristics. And you probably want to bring this all into your environment, likely using Databricks, and start to see if you can't uncover some patterns and relationships between the data. So I guess I would want to know, how's this going for you? But it's a trick question, because I actually know the answer, that it's not going that well. Data is absolutely the hardest part of AI and ML projects across the board. It's incomplete, it's disparate, it's unreliable. You're getting it from a bunch of different vendors trying to bring in third-party data, and essentially all these issues coming together to create project failure. On top of that, this desire to include location is causing issues because location data is incredibly complex. It's not that easy to just extract attributes from a spatial data set and join them to location data or address data. It's computationally intensive, and at this time, it does sort of require specialized skills. So we're seeing folks all over the board dealing with tons of project failures, and the biggest problem that we're seeing is a lot of people don't want to get started at all. They just see it as this huge roadblock, and they sort of scrap the projects altogether. And so we want to help enable and accelerate this process. So we've essentially, working with Databricks, have put together a location-enabled lakehouse on the Databricks platform using our software and our data. And it's really essentially a three-step process. So the three steps are organizing, enriching, and analyzing the data. Step one, the organization process, involves a couple different things, but primarily geocoding, which is the conversion of an address to a location. And then with our geocoder, we also assign a trusted ID, which we call a Precisely ID. And that's a unique and persistent identifier that stays with an address in perpetuity. So once you've converted an address, you can sort of track it throughout the entire data science process. Another piece of the organization puzzle would be our ability to connect legacy data up into modern data cloud platforms. So sort of once you get all of your location data and your legacy data, and then any other data that you have on any systems, whether they're on-prem or in the cloud, bring that into Databricks. That's when we can really start enriching and adding context to the location. So during the enrich phase, we can use that Precisely ID to link up with our full 10,000 attribute portfolio of data, as well as extract information from any third-party data sources you have or your own organizational data. And we can do that using our spatial SDKs that we've enabled in Databricks. So what that's going to do is allow you to do things like buffer and find nearest and aggregate by different geographies to uncover patterns in your data. And then lastly, now that you've organized and enriched all your data, you have this huge pool of data to apply data science at scale to gain this competitive advantage by allowing you to power business decisions quickly and effectively. And because we've enabled these spatial SDKs, you can basically pre-bake spatial calcs into the variable set for machine learning. So this is sort of what the solution looks like on more of a high-level diagram. So let's continue pretending we're in the insurance business. Could be true. So basically, all of your sources on the left, you can see streaming into the Databricks platform. Some of you may know Databricks supports any structure or frequency. So this could be semi-structured data, unstructured data, classic databases, and then it could be streaming or batch, what have you. Whatever you have, just bring it into Databricks, and then we can start to organize it around the Precisely ID, use those location intelligence capabilities to sort of get the most out of everything that you have, and then start enriching it with our 10,000 attributes. So if you look at the purple boxes along the bottom of the screen, you'll see we have data sets ranging from physical risk to population and demographics, different information about the physical structures themselves, and then also dynamic weather. And I'm going to talk more about that in a second. But basically, all of these data sources together can fuel these capabilities on the right hand of the slide. So whether you want to start looking at different relationships between things like weather and structures in an ad hoc data science method, or do actual predictive modeling with machine learning to create the likelihood of an event impacting your policies. Also, we see a lot of reporting and dashboarding, the typical business users just looking for something that can drive decision making with little to no input on their part. They basically just click a button and they're given information to do their job. And then, of course, real-time applications. So we see a lot of demand for automated workflows. So if some sort of event could trigger auto claim, auto disbursement, very relevant in the dynamic weather space. So I will show you. Let me see if I can get this to play. Maybe not. So I wanted to give you just a little bit deeper dive into the dynamic weather because I think it's so important for machine learning and data science applications. This is an API-driven weather data delivery solution, but we also have aggregated and created these bulk products that basically reach back decades with high-resolution weather data so that you can feed your models with this rich data. And just in insurance alone, this is incredibly powerful for claims predictions, actuary process, underwriting, developing moratoriums, things like this. But I mean, if you think back to those verticals in the beginning of the presentation, we see major applications in the telco space, thinking about network reliability and energy demand and things like this. So lots of different use cases for the dynamic weather product. So let's see what's next. Oh, there it's playing now. So this just shows you what you might use this for to track different weather conditions such as fire and smoke occurrences associated with wildfires. So wildfire is obviously a huge topic right now, and is going to continue to be as the climate changes. So I think it's time for a quick demo. Let me just pull that up real quick. All right, awesome. So this is sort of a sample end product of what you might get after going through that organize, enrich, and analyze process as the data scientist. So you've taken advantage of our geocoding, you've taken advantage of your organizational data, and then possibly some third-party data that you've purchased, and then brought it together with different products such as wildfire data, property attributes, and different dynamic weather data to sort of reveal patterns between those different data sets. So what we have here is a tool that we would provide to a category, or excuse me, a CAT manager at an insurance company, which is like a catastrophic event manager. It's their job to sort of delegate resources in the face of a catastrophic event. So essentially, what we've done as the data scientist is we've pulled all the policies, and then we've geocoded them using the geocoding SDK, and then intersected it with our wildfire model. So we can see, of our book of business, how many of those properties are at high risk of wildfire. And from there, we can go on to sort of highlight from that subset, is there any additional risk? Where is it? Who are the customers? And sort of how can we prevent risk or prevent damage from happening to our book of business, and then also help customers that are in need. So we have the total number of high-risk properties, and then we've pulled day 1 and day 2 fire weather, which basically tells you what the accelerated risk is 1 day and 2 days out of the event. And this is something that we've sort of uncovered in different ad hoc data science experiments. And then, of course, insurance company, we're going to want to know how much money's on the line. So there's a lot of financial implications during catastrophic events where you need to make a certain amount of money liquid. So this is an extremely important diagnostic to be able to just quickly roll up using geospatial technology. As we scroll down a little, we can see, obviously, you have to have a map. It's incredibly important to be able to understand the geographic distribution of risk and sort of get an idea of if there's pockets that are at particularly high risk. These types of analyses can inform inform an insurance company where they should not write business. Because there's always people that will call a day before a hurricane hits or something like this, try to get insurance coverage. So I'm just going to keep scrolling down. I just want to show you what some of the property attributes look like. So here we've pulled a couple of attributes that describe how well the building is fireproofed. So incredibly helpful for telling you, sure, you have a bunch of high-risk properties, but perhaps they're made out of extremely flame-retardant material, so you don't have to worry. But it looks like that's not necessarily the case here. We have a lot of wooden structures. So just little pieces of information that sort of build the story of how at risk your book of business and where those buildings are, and if there's anything you can do to stop damage from occurring. Also pulled land use here, just to get an idea. Perhaps there'd be a pattern of vacant land or some sort of attribute in the land use that would dictate if there was a higher or lower risk. But it seems like it's mostly single-family residential here, so the risk is still pretty high. And then these types of dashboards are extremely helpful for feeding large-scale metrics and making just quick decisions on the fly on operations and logistics and things like this. But in insurance and in most businesses, individuals matter and customer satisfaction matters. And so this last table here, as opposed to some of the higher level metrics that say, hey, we've got $1 million on the line, do something. These are individual people with extremely high fire risk and extremely flammable materials that their buildings are made out of, and then roof shapes and roof cover and fuel types that are associated with higher wildfire risk. So these are homes that were already in a high area and have characteristics that indicate they might have an accelerated risk. So in a lot of cases, you would probably want to reach out to these customers and provide some sort of fireproofing tips or evacuation orders, help them be safe, and also improve your relationship with them. So I think that about does it for the demo. So I hope that that helped illustrate really how it precisely works on Databricks and how we can help accelerate and enable your machine learning initiatives using our data and software. So Mayank, I'm gonna pull you back up here when you're ready, and we'll have Mayank go into the Precisely ID.
Hey, my name is Mayank Kasturi. I'm from Precisely, and my friends and colleague also call me Lock. By the way, what's the job responsibility of a locksmith? To make keys, right? And this locksmith gonna make keys for your address, and how about all the addresses in the United States? Ladies and gentlemen, Precisely ID. This ID you can generate from using our geocoder, and the process of geocoder is taking an address and producing latitude, longitude. Not just the latitude, longitude, but an exact building rooftop level latitude, longitude, which can help you to make better decision. And I will show you how. This ID, it can be treated as a primary key for your data. And the best part about this is it's persistent, which is if tomorrow your address or your city decided to change the name of your street, instead of pointing to another ID, it will point to the same ID. 625 Manhattan Place, Boulder, Colorado will point to PBID1, and 625 Highway Place, Boulder, Colorado will point to the same ID because the city decided to change the name of the street, but not us. So it's gonna point to the same ID, and there is no mismatch in the data when it comes to the data engineer to maintain the data and for the data scientist to make a better decision. Coming back to data scientist and data engineer, it's very difficult when it comes to share the data among your partners, your friends in the company, and then there are security policies because you're sharing a user data which has an address, right? So how about sharing 10 or 7 address attributes or address information? We just use one ID, which is Precisely ID, with our vendors or with our friends, which is our partners. Moving to the best part about this is this can open the door, just like your own house key can open the doors for all the rooms in your house. This key gonna open the doors for 10,000 other attributes, which is static and the real time, to your address data. And now, coming back, the topic of our conversation, which is Turbocharge, the machine learning and AI using Precisely, that's how we're gonna do it because we have a data. There is an argument that having 10,000 attributes can also give you false positive. Overwhelming number of columns or overwhelming number of attributes is not good. I agree, but it's not good when the data is not good. It's the best thing ever happened to an address data because it's an accurate data. Starting from exact to connected, we will give you point level location, we will give you best out of breed location and the demographic data. Then before leaving from this slide, I want to say if I want to give an adjective to all the characteristics of my Precisely ID, any guesses? How about now? I think it's an epic key, right? It defines the epicness, and it's going to solve a bigger and most difficult problem. As Diana Smith showed us how an underwriter or an employee at the insurance company will have to make a better decision using the notebooks. She showed you a demo on Databricks. How about you and I, we solve it together and how we architect that same notebook. Being an underwriter, I have a notebook and I have policy addresses. What I need is whenever I come to my desk tomorrow morning or every morning, I want the best and the updated addresses, right? You can take historical addresses and keep on making decisions for 1 year, or you can take the historical addresses, do some magic with it so that you can get the last night dynamic weather attributes too. So how about I'll show you the next step. we have the policy address, and before taking the policy address and move it to the notebook, how about we massage the policy address? We massage the policy address with the available third-party data, and it can be structured, unstructured, and the next best piece is the spatial data. It can be boundaries, right? So you have your policy data, and you want to massage it with or enrich it with your partner's spatial data. You can do it using our geo-addressing, and you can see how policy addresses are coming from our geo-addressing, right? Using the Databricks engineering notebooks. Next to, you can see the data experience and dynamic weather. Data experience is our static data set, which updates, I guess, it depends, but it updates quarterly or monthly. It depends on the data set, and as you know, it's 10,000 attributes, couple hundred data sets, so it has different updates timing, but it's not every day, right? And it's not even possible. So taking that static data from our marketplace, we will take that data, and we'll also take the dynamic weather using the Spark streaming or any streaming services, and merge them together with no guesses, precisely ID, and it's going to become a best out of the breed data available to you as a data frame in case of Databricks, or as a table in case of SQL, and then you can apply your machine learning algorithm. And as I said, this is the best data. It's going to point you to a point level location. It's going to give you most accurate data based on the static data which we are showing from our data experience, and dynamic weather data coming from last night's weather event. That enriched data will then be served to the engineering, to the analytical notebook, and it can be scheduled every morning. So whenever I'm having a cup of coffee, instead of worrying about updating the data, it's going to update every morning for you. You will see different number every morning, and you make a bit better decision whenever you have to run the analytics next time. As we have known that we started attending this conference, and Databricks started to release their lakehouse and telling us more about it. It was very easy to connect the dots and connect how we can use the lakehouse moving forward. So our data experience, as we know, as I have told you, like this is a marketplace. We already planning to bring most of our data sets to the marketplace. We can bring it in the lakehouse too. Using the data engineering, we can do the geo-addressing module, and then using the streaming, we can do the real-time weather data. We can bring the real-time weather data, and all together, this will be the lakehouse compatible solution. So that's how an underwriter will make a better decision, and they can use their machine learning algorithm, and they can turbocharge their available data and make better and better decision. Next is why do we trust Precisely, right? Who are we? So as you can see, like we are the data integrity leader, and what next we have is the DI suite, which can cover everything around the data, starting from connect to verify, then do the location intelligence, and then enriching it with 10,000 attributes. It's going to happen at the same place, and we'll have available connectors for Snowflake and Databricks, Redshift, and many more. About the brands who are our customer, we have 12,000 customers across the globe. Fortune 100 companies, they all are our customer except for one, and then we are available as our data and as an existence. We are available in 100 countries. And that's pretty much it. Any question? H3, yeah. So H3, if you have seen, it's kind of a polygon, right? It's a shape, right? And it can vary because it has 16 different levels. So you can cover the whole United States, or you can cover where the place I am standing. What precisely ID is, firstly, it's around the addresses, right? And it will give you an exact rooftop level location for your data. So Carto versus us, they are working around the demographics and risk based on H3 model, and that can cover like 3 or 4 houses when it comes to matching, right? But when we're talking about precisely ID, all 3 houses or properties has its own identified unique ID. Does it make sense?
Yes.
Thank you. Do you have any other question?
So in that case, right, if that property changes, say it goes from 1 parcel to like 5 parcels.
Yes. So if it goes to 1 parcel to 5 parcel, and you have, first of all, the challenging part when it comes to hex is you can't. How do you decide which hex level to come up and follow up in your model? But let's say you have decided 1, and then it is covering 1 parcel. But now the same person, the owner of the property, by the next 2 parcel or next 4 parcel, then it will be pointing to 3 other hex, because hex 1, hex 2, hex 3, it will have different IDs or identifier. But in case of precisely, as I said, it's persistent. Tomorrow, if you buy the next 2 parcel or 5 parcel, it will still point you to the 1 precisely ID.
No, I think you misunderstood my question a little bit. That is, you have 1 parcel that gets redivided into 5 parcels.
Okay, so if it is redivided, in our case, it will have 5 different precisely IDs, and the previous, so it depends how you redivide. If it redivided into units, then we have a base address, and base address will have 1 precisely ID, and all the units will have their own precisely ID, and then we have the mapping from 1 precisely ID to 5. This is in case of units, but if you say 5 addresses came together and become 1 address, then that 1 address will have the same will have 1 precisely ID, and all 5 will come back, will go to the change logs. So it will stay there for all 5, but because the address is no longer available because of the updates, ultimately the new precisely ID will be there, and those precisely ID will be retired.
In between.
So it will be updated in the next release of the data. So right now I have 45 and 55, and then there is a parcel which doesn't have any address, then that parcel won't contain any precisely ID.
So what happens to the old 45 ID?
It will remain 40 as PBID, whatever the ID is. If it is P001, then 55 is P002, and then new additional IDs will be P003, 4, 5, 6, 7. And I'm talking when 45 is unrelated to the central parcel, because that is not.
In this case, it's related in the case that 45 gets divided up.
So 45, then 55 is the 2. Just leave it. But 45, 40, and then all the new will assign the new precisely ID. 45 will remain there, and then there will be mapping that these 46, 47, 48, 49 are related to 45.
Right. So what does the precisely ID then recognize that 45
is a parent ID.
say demolished and is now only somewhere else?
So we will retire that precisely ID. Okay. So it's basically address to an ID. And however, the journey of an address moving forward, if it is not going to remain, then there is no point of having that precisely ID. So but if you use the SDK, it will tell you that it's that old precisely ID and it's going to retire soon or whatever.
Okay, so just to sum it up, so
like you say P001 and P002 will be neighbors. It's not necessary, because we haven't generated precisely ID based on the sequence or an array. We created, it's a secret sauce, but we created based on the address, like the string address, 625 Manhattan Place, Boulder, Colorado. So we take it, take out the spaces, hex it, something, something, and then created the ID. So it's not even possible that one precisely ID it will be sequential to the next one, because it will breach the security, right? If you have some data regarding a precisely, and you have precisely ID, you share it to someone, then it is very easy to predict what is 624, right, if it exists. So it's it's not sequential at all. And we also, when I talk about the spatial data, like spatial UDFs, we also support the geohashes, which means like you can also program the geohashes, and then if you have any use case around geohashes, precisely can also solve that use cases. Any other question? Awesome.
Related to that question,
Sure.
so you're not running like queries based on that precisely idea.
I'm sorry.
So you're not really running queries based on that ID, it's just unique ID.
We are running, because when we talk about joining 10,000 attributes, how do you join it? It's simple sequence SQL joins, or when we talk about Python, it's Python or any language you want to use, you just have to take the data and join it together. So in order to join, you need a primary key from one data table and foreign key from the other table. So our enriched data, say risk, and in risk we have flood. So flood has precisely ID versus all the columns of the risk, fire station, nearest fire station, and everything, 911 call and whatever. So everything will be joined to a key named precisely ID in our database, and then your user data or policy data will be an address or location. We will append the precisely ID, and now this primary key can be joined to the primary key of the other data set, and you can join other risk data set to your policy data.
And they all have a latitude and longitude.
Yes.
I think that's what you're getting at, right?
In a sense, because obviously you can do the like a spatial join with the address. Like if I want the property, I have a precisely ID and I want the properties around it.
Mm-hmm.
Right? You would be doing a query for like stuff around it.
Yeah, so we can do the find nearest.
Specifically using that ID to find the ones around it. You're using.
We have built out a relationship table that links all of the address points, the buildings, the parcels, the property attributes together via IDs, so that people don't have to do that additional processing. So we do have a master link file, and it's pretty complicated. It's not just, is the address point inside of the building, is it near it, does it share a parcel, et cetera. Things like that. And we're working on building in shared ownership to that, so that I think maybe some of the use cases you're talking about deal with adjacent parcels and subdivisions, it can sort of address those issues.
Can I suggest to take this?
Yeah.
Sure.
At the time, looking for questions.
Yeah, happy to discuss further.
Thank you.
Thank you, everyone.